Today we're going to learn the quadratic formula and talk about the discriminant. We're going to use the quadratic formula to find real roots of quadratic equations. We're going to use the discriminant to find the number of roots of a quadratic equation, and then classify and find all roots of a quadratic equation. Our first method for solving was by factoring and then setting each piece equal to 0. So if we have x squared minus 5x plus 4, that's going to factor to be x minus 4 and x minus 1. And negative 4, negative 1, multiply to 4, and add to negative 5. So we set each factor equal to 0. X minus 4 equals 0. When we solve, we get x equals 4. When we take x minus 1 and set it equal to 0, we solve, we get x equals 1. So we can graph this by putting it at 1, that's at 4. Right now, before the vertex, we just have to open up, and it's going to pass through x equals 4 and x equals 1. Okay, but what if you can't factor? So we learned completing the square. You can use completing the square to solve, but you can also use the quadratic formula. So the quadratic formula, I'm sure you guys have seen before, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we want to find the solutions to 2x squared minus x equals 4, okay, the first thing we have to do is to write it in standard form. Okay, that means we have to set it equal to 0. So we're going to take 2x squared minus x minus 4 equals 0. So we're just going to subtract the 4 over. Okay, we're going to identify a, b, and c. So my a is 2, my b is negative 1, and my c is negative 4. Okay, so now we're going to plug this into the quadratic formula. So x equals negative b. And since b is already a negative 1, we're going to make it a positive 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c, all over 2 times a. And it's important that it's all over 2a, so you're not just dividing the radical part by 2a. Okay, so if we solve this, we're going to get 1 plus or minus. On the inside, we'll get 33, and denominator, we get 4. And we'll leave our answer just like that. Okay, so what are the solutions to this? So set it up, plug it in. A equals 1, B equals 6, C equals 9. So we're going to do x equals negative b, so negative 6, plus or minus the square root of 6 squared, minus 4 times a times c, all over 2a. So when we do this, we get negative 6 plus or minus the square root of 36 minus 36 over 2. Now when we do 36 minus 36, we're going to end up with 0. The square root of 0 is just 0. So we end up with negative 6 over 2, which is negative 3. And if you were to factor this one is factorable. What multiplies to 9 and adds to 6 would be x plus 3 and x plus 3. So if you solve it, you're only going to end up with negative 3, like we got. Okay, let's solve this one. Okay, make sure it's equal to 0 before you start plugging it into the formula. So first we have to add the 3. So we have 2x squared minus 6x plus 3 equals 0. Okay, we're going to plug it in. So x equals negative b, so it's going to be positive 6 plus or minus the square root of b squared minus 4ac all over 2a. So if we solve this on the inside, we get 36 minus 24 plus or minus 2 radical 3 over 4. Okay, you always have to break down your radicals if they can be broken down. And now, all of these values can be divided by the same number. Okay, we never want to divide the radicand. So even if it was radical 6 instead of radical 3, we don't want to divide it. We always leave it the same. So everything can be divided by 2 here. So we're going to end up with 3 plus or minus radical 3 over 2. Okay, so I'm just going to go through these 3 examples and just follow along and take notes. Okay, so we're going to plug it in. 9, so it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And 9 plus or minus the square root of 81 minus 20 over 2, which equals 9 plus or minus the square root of 61 over 2. And the second one, we have to set it equal to 0 first. So we're going to add 2. So negative 2x squared plus 4x plus 2 equals 0. And I'm going to plug it in. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 4 plus or minus the square root of 16 plus 16 over negative 4. Negative 4 plus or minus the square root of 32 over negative 4. 32 can then be broken down. So x equals negative 4 plus or minus 4 radical 2 over negative 4. And then again, we can reduce all of these by a negative 4. So I'm going to divide this, and this by negative 4. So I end up with x equals 1 plus or minus radical 2. Okay, and on the last one, I bring everything over to one side, so it's equal to 0. So I'm going to have 3x squared plus 5x minus 2 equals 0. So I added 5x and I added 1. So now I'll set it up. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have x equals negative 5 plus or minus the square root of 25 plus 24 over 6. So negative 5 plus or minus the square root of 49 over 6. And the square root of 49 is a perfect square. So we have negative 5 plus or minus 7 over 6. Since we have a number that doesn't have any radical now, we could have solved this by factoring. So if you get rid of all your radicals, you're going to solve this twice. So since negative 5 plus or minus 7 over 6 is what x equals, you're going to do it for when x equals negative 5 plus 7 over 6, and also when x equals negative 5 minus 7 over 6. So with negative 5 plus 7 over 6, we're going to get x equals 1/3. And when x equals negative 5 minus 7 over 6, we're going to get x equals negative 2. Okay, so let's look at this problem. So we have the equation h equals 80t minus 16t squared, and it models the height h in feet reached in t seconds by an object propelled straight up from the ground at a speed of 80 feet per second. At what time will the object hit the ground? So if we think about this, it's getting thrown and it's landing. So we want to know right here, and where it hits the ground. So this is our x-intercept. We know that one of them is at 0. Here's 0, 0, that's where you start. We want to find where it lands. So we're trying to find the other 0. So we're going to set this equals 0. I'm just going to put it in the correct standard form. So negative 16t squared plus 80t equals 0. So I want to solve this now. So I could factor it, or I can use the quadratic formula. So let's do the quadratic formula. So instead of x, we have t. So t equals negative b, so negative 80, plus or minus the square root of b squared minus 4ac. And my c is 0 since I don't have any constant term. All over 2a. So when I go to solve this, t equals negative 80 plus or minus the square root of 6400 over negative 32. So I end up with negative 80 plus or minus 80 over negative 32. So again, there's no radical here, so we're going to break it up into the two possible answers. So one way is negative 80 plus 80 over negative 32. So in this case, negative 80 plus 80 is just 0. So one answer is t equals 0. And that's where it's starting from. That's our starting point. That's where t equals 0. We care now about where it lands. At what times will the object hit the ground? Well, it's going to hit the ground when it starts. And then it's going to hit the ground at the end. So that's going to be option 2. Negative 80 minus 80 over negative 32. So that is going to give me